The product theorem and quotient theorem is going to be pretty easy to do in polar form. In fact, it's easier to do in polar than it is in rectangular, which you may not believe that, but check it out. If I'm trying to multiply two polar form vectors, it's going to look something like R1 cis theta 1 times R2 cis theta 2. What will happen is you're going to multiply the two R numbers, R1 times R2, and you're going to add the two theta numbers. Okay, that's it. That's the formula. So equals. The quotient theorem does something similar. If you divide R1 cis theta 1 by R2 cis theta 2, you could probably guess what's going to happen. You're going to divide the two R numbers and you're going to subtract the two theta numbers. So very simple if we're in polar. So check it out. Example 6 has one of each. Part A is the product theorem. So literally all we're going to do is multiply the two R numbers. You get 2 times 3 is 6. And add the two angles, 45 plus 135. Is 180. You're going to get 6 cis 180. That's it. That's all there is to it. That's the product theorem. So the quotient theorem, we're just going to divide the two R numbers. 36 divided by 4 is 9. And we're going to subtract the two angles, 9 cis 2 10. It's much harder to convert back and forth between polar and rectangular form. That is it for product and quotient. So look at number 7, okay? 7a is just a direct use of the product theorem. We're going to multiply those two numbers. 12 times 5 is 60. We're going to add those two numbers and get 150. Okay. Now, part B, don't move on. Part B, notice, is in rectangular form. Even though, here's some irony for you. Even though we're more comfortable with rectangular form, it's actually harder to multiply in rectangular form. It's not that we don't know how to do it. We've done this before a million times. If you were going to multiply, you'd do distributive property. 2 times 4 is 8. 2 times negative 5i is negative 10i. 3i times 4 is plus 12i. 3i times negative 5i is minus 15i squared. We'd do what we always do here, and we'd say I squared is negative 1. So that means minus 15i squared would be plus 15, and we would combine our like terms. 8 and 15 makes 23. Negative 10i and 2i makes plus 2i. So we can still multiply. It's just easier to multiply in polar form than it was in rectangular form. Part C looks like we're dividing. So use that quotient theorem. We're going to divide. 120 divided by 40 is 3. And we're going to subtract 180 minus 30 is 150. I will do those problems all day long. But in rectangular form, that's a little harder. We did this in a previous section. We had to multiply by the complex conjugate here. 2 minus I over 2 minus I. Actually, we're multiplying by 1, but we're multiplying by a special form of 1 using the complex conjugate. And we're going to have to FOIL or distribute. 4 times 2 is 8. 4 times negative I is minus 4I. Negative I times 2 is negative 2I. Negative I times negative I is plus I squared. On the bottom, 2 times 2 is 4. There's a shortcut if you see it. 2 times negative I is negative 2I. I times 2 is plus 2I. I times negative I is negative I squared. I squared is going to be minus 1. Negative I squared would be plus 1. These two cancel each other out. So look at what we have. On the top like terms, 8 minus 1 is 7. Negative 4I, negative 2I make negative 6I. On the bottom, 4 plus 1 is 5. I like the answer written like this. I suspect Math Excel is going to make you split it into 7/5 minus 6/5 I. Either way, same thing. There's your answer.